Hello, tomorrow we have a quiz and I'm out today, so if you have any questions during the presentation or you want the substitute to pause the presentation, please say pause. And also use Remind. I'm going to send out a text message, or I should have already sent one out via Remind saying use this text message to ask any questions during the presentation. So with that said, I'm going to go through a problem representing each section of your quiz. Your quiz is front and back. There's 19 questions. There's about 2 questions per section. So in this section, actually, I just realized there's a section that's not even, it should almost be the very first problem. It talks about rewrite in the exponential form. So if we had rewriting of log base 2 of 8 equals 3, so the first section is all about rewriting. If I want to rewrite, I'm going to put that in exponential form using the circle. 2 to the third power equals 8. So the very first section, I'm looking for answers of rewriting in the exponential form. The next section is simplifying an expression without using a calculator. So with this, sometimes it's helpful to set it equal to x and see what it would come out to. So 5, using the circle, 5 to what power equals 125. And we could say, okay, this is going to simplify to 3 because that's what that exponent has to be. Or another route, if I turn 125 in terms of 5, well, 125 is 5 cubed. I don't need parentheses. Is 5 cubed, and using the property of log base 5 of 5 to a power undo each other, and you're left with 3. Both strategies work. I think I'm going to stick to this one a lot more since we'll use it to graph. All right, I'm going to do another example of this. So this one, log base 1/2 of 16, again, evaluating without using a calculator or simplifying without a calculator. If I was thinking about how could I put 16 in terms of 1/2, but that might be too difficult. So if I set it equal to x and ask myself, okay, 1/2 to what power, using the circle, 1/2 to what power equals 16. This is a problem where I should put them in terms of the same base. 1/2 is 2 to a power. 16 is also 2 to a power. 1/2 can be rewritten as 2 to the negative 1 power raised to the x. And 16 can be rewritten as 2 to the 4th power. And technically I don't need parentheses here. But when you have a power raised to a power, you multiply powers. So 2 to the negative x power equals 2 to the 4th. In this case, we can zoom in on those exponents. Since the bases are the same, negative x needs to equal 4. Divide by negative 1 on both sides. This expression will simplify to negative 4. So I either could say x equals negative 4 or just the answer negative 4 is fine. So in the next section, you're going to have to find the inverse of a function. And when we do that, the first step is to switch x and y. So switching x and y, we get x equals log base 2 of y. And then we have to get y by itself somehow. You could either use the circle to, I actually taught 6th hour different from 7th hour. And I'm going to use the 7th hour strategy. But you could rewrite, taking the base 2 to the x power equals y. 2 to the x power equals y. Well, and this is the inverse, so let's indicate it that it's the inverse. I had mentioned how we could use f inverse of x or just y inverse. Either one of those are okay. So I'll say this function's inverse is 2 to the x. On the next problem, next section is about graphing. And we talked about how we need to use the cut graph. So if I were to cut this graph, log base 5 of x plus 2, I'm going to cut this graph saying that the function is equal to log base 5 of x. So looking at this, I'm going to choose nice numbers. The two nice numbers we plug in is the base, because if we have log base 5 of 5, it's going to be simplifying to 1. And we're also going to use, so 5 is going to be plugged in, and then we're also going to use 1 always. If I plug in 1, log base 5 of 1 will always be 0. Let me show you those steps. So the little steps, log base 5 of 5, these undo each other, and you're left with this exponent of 1. The other one, log base 5 of 1, if you ask yourself 5 to what power, 5 to what power gets you 1 by rewriting, it has to be 0. So these are my points, 5, 1, and 1, 0. The thing about this is this is going to translate. We've got to determine, is it an H or is it a K? And since it's in parentheses, H is equal to 2. Whoopsies, hold on. H has to change its sign when you analyze it. So H is actually equal to -2. Meaning we're going to translate left 2. And then the domain is also going to change. And the asymptote changes. So if I were to sketch this graph, instead of having the point 5, 1, instead of having this point, I'm going to translate it left 2. So now it moves left 2. We're at 3, 1. And instead of 1, 0, so instead of 1, 0, it's also going to translate left 2, being at -1, 0. And our asymptote, instead of being x equals 0, like typical, it's also going to translate left 2. So let's actually write that down. Asymptote is going to be x equals -2. So I will have a dashed line going through x equals -2, and I'm going to make sure I don't pass that line. If you pass it on your quiz tomorrow, I'm going to be taking points off. Notice the shape. Shape is not passing the asymptote. It hits that -1, 0 point, starts sloping off. It should not look like a right angle. I noticed that in some of your homework, that we were making logarithms look like right angles, and this should not be a right angle. It should be a curve. So if the asymptote is x equals -2, the domain, the x coordinates will have to be bigger than -2, and the range is all real numbers. I'll be looking for this tomorrow. So, next problem. You will have a condensing section. And actually, my bad, the condensing section is after the expansion section. So when it says condense, I have to undo. So the first step will be to undo the power rule. And then the second step will be to undo product or quotient rule. That's how we condense. So to undo powers, we're going to look for coefficients and raise them to be a power. So I notice my one coefficient, I'm going to take that 3 and raise it to be a power of 2. So far we have log base 4 of 3 plus log base 4 of 2 cubed. So in the next step, I'm going to undo product or quotient. I notice I have a plus sign, so it's the product rule. Undoing this product, I'm going to have 3 times 2 cubed. So we're going to have log base 4 of 3 times 2 cubed. We have 3 times 2 cubed. Last step is to simplify or make it, clean it up. That's what I say in class. So 2 cubed becomes 8. And our final answer, log base 4 of 24. Power rule will be the easiest to remember because it's the only one where, okay, a coefficient becomes a power. But you will have to determine, you'll have to memorize that if you see a plus sign between two logarithms of the same base, that turns into multiplication. If you see a minus sign, that's the quotient rule. So let's look at an expansion. In this, so now I'm going to expand using the product or quotient rule first. And the last step will be to use the power. It reverses what we just did. So I noticed there's a product between 4 and y, and then a quotient with z cubed. So if I'm doing product and quotient all in the same line, I'm going to have, okay, product between these two. So there will be a plus sign between these two logarithms, and then a minus sign for the z cubed logarithm. And I'm going to use ln, natural log. So I'm going to have the natural log of 4 plus natural log of y minus natural log of z cubed. Notice how I separated the product with a plus sign, separated the quotient with a minus sign. Now I'm going to take care of that power, and final answer, natural log 4 plus natural log y minus 3 natural log z. The very last section of your quiz talks about, I want you to use the change of base formula, and you're going to round to 3 decimals if necessary. I have to see the change of base formula. If you just give me an answer, you're going to get points taken off. Yay for you for finding the answer, but I don't see you using the change of base. Some people have calculators that you can just plug this in, and but you're not showing me that you have this knowledge. So change of base is another thing we'll have to memorize. Change of base uses either the common log or the natural log. Because this, typically I just go with common log since I already see log here instead of ln. So I'm going to use common log, and we take the argument first. The argument will be the first common log. The base will be on bottom, will be in my denominator. So common log 8 divided by common log 4. And you should be getting an answer of 1.5. So I don't need to round to 3 decimals. It's not necessary. On the quiz, however, tomorrow, you will have a situation where you will need to round to 3 decimals. So if you have questions, we're going to pass out, the substitute will pass out a worksheet at this point in time, and answers are posted up in the back of the room. So please do the worksheet. It relates to the quiz, so that way you can practice on your own and ask questions using Remind. So thank you.